our trig unit. We're going to be looking at calculating angles today when we have when we're given the sides. So before we jump into it, though, let's look at the review first of all. So when we're given a ratio, such as in this case over here, we would be given a ratio, and we're looking for the angle. Remember, on your calculator, you have to go inverse sine in order to get the angle. So again, so anytime you're looking for an angle, make sure you do inverse sine. So to get this angle here, we'd have to go second function sine 0.45 in order to get the angle. So 26.7, which would round up to about 27 degrees. Same thing for B and C. So go ahead and try those first. Okay, and again, read through this and follow the steps. See if you can calculate the angle. I'm going to jump right into example number 1 down here. Okay, I'm looking for angle A, and I'm given the opposite side and the hypotenuse side. So if you remember from SOHCAHTOA, the three ratios are sine, cosine, and tan, and sine is the one that deals with the opposite and the hypotenuse. So it's going to be sine angle A is going to be opposite over hypotenuse 4/6. And if you're still not really sure why it's 4/6, make sure you go back and watch video 1 just to recap on the three ratios. Okay, so in this case now, to get angle A, I'm going to go A equals sine, or rather inverse sine, 4/6. And on my calculator, that would be inverse sine 4 divided by 6. So 41.8 or 42 degrees, as we rounded up their nearest degree. Okay, go ahead and try B. I'm going to jump right to C over here. I'm looking for angle C, and I'm given all three sides, which is a bit of a bonus because I can choose any ratio once I have all three sides. I'm going to go ahead and do tan. So tan angle C is the opposite over adjacent, which in this case is going to be the opposite here and the adjacent over here. So 21/20. C would equal inverse tan 21/20. So on your calculator, get your calculators out and go second function tan to get the inverse tan, 21 divided by 20, and we end up with 46 degrees rounded to the nearest whole degree, so 46 degrees. Okay, let's do some more problems down here. Okay, quickly, some definitions. We have the angle of elevation and the angle of depression. So the way I look at it is anytime you're looking up, it's the angle of elevation, and anytime you're looking down, it's the angle of depression. Now both angles are measured from what's called the normal, which is the line that's parallel to the ground or the ground itself. So so in this case here, this would be the angle of elevation, and this would be the angle of depression. And just note that they're both measured from the horizontal line, not the vertical line. So you're not looking for this angle here. You're looking for the angle that's measured against the horizontal line, and the same thing for the angle of depression. It's not this angle that we're interested in, rather it's this one over here, these two here. Okay, so let's go ahead and jump into some problems here. So now we have, again, word problems that are very useful. Trig can help us solve these word problems just like we did last class. And in this case, we have a tree that's 5.1 meters. So go ahead and label your diagram as soon as these heights are given to you. So the tree is 5 5.1 meters tall, and it casts a shadow that's 7.5 meters long, so 7.5 meters down here. Calculate the angle of elevation of the sun to the nearest tenth of a degree. So you have to kind of picture this now. If the shadow's here, let's do a little sun here in yellow. You're gonna have oh, that's not a very good sun. Okay, well, good thing it's not an art class here. There's the sun right there, and the sun is sort of shining rays this way, and it creates the shadow down here. That's 7.5 meters. So let's label the thing we're trying to calculate, and that is the angle of elevation to the sun. Well, if I was standing down here, the angle of elevation would be, me looking up at the sun, and that would make, would be this angle over here. Let's call it x, just so we are clear with what we're looking for. Okay, so x in this case, what ratio is going to be involved in this example? And with respect to x, we have the opposite and the adjacent, so that would give us the tan. So tan x equals 5.1 over 7.5, and then x equals inverse tan 5.1 over 7.5. And with your calculator, inverse tan, well, running the batteries here. Here we go. There we go. Okay, so inverse tan 5.1 divided by 7.5, 34 degrees. So, tenth of a degree, so 34.2. So 34.2 degrees is my angle. Let's see if that makes sense. In this case, it does make sense because, well, we got an answer that's between 0 and 90, so we're looking good there. But it doesn't make sense in terms of the ratios that were given or the length of the sides. Well, yes, because if the tree was more than the shadow, in other words, more than 7.5, this angle would be more than 45 degrees because these two would be about the same. Now, because 5.1 is less than 7.5, this angle is going to be less than 45 degrees. As this angle grows, so does the length of the opposite. So our answer makes sense, and always check that to see if your answer makes sense before you move on. Let me see how many more angles I have, or questions I have. So this one's pretty quick, this lesson. I'll try and do another question quickly here. A boat is 130 meters from the base of a cliff. The cliff is 80 meters high. Draw a diagram to represent this scenario and mark the angle of depression of the boat from the top of the cliff. So let's do here's our cliff, and then we have some water here. I can do the cliff in green maybe just to signal the cliff there. Okay, the cliff is 80 meters high. Let me go ahead and mark that. 80 meters high, and the boat, oh, we don't have a boat yet. Let's make a boat here. There's a boat, with its sail there. And the boat is 130 meters from the base of the cliff, so this is 130 meters here. So not quite to scale here. I messed up a little bit. The cliff should either be higher or the boat should be closer, but that's not important as long as we understand what the diagram presents. So the angle of depression would be this angle down here. So as I'm going towards the boat, and remember, we always measure from the horizontal. So we're looking at this angle over here from the cliff to the boat. So let's calculate the angle of depression of the boat from the top of the cliff. So with respect to our angle x over here, the opposite side, which is the cliff, and the adjacent side, which is the distance from the cliff to the boat, would be the tan ratio. So it would be tan x equals opposite over adjacent, so 80 over 130, and then to get the angle, we would go inverse tan on our calculator, 80 over 130. Let's go ahead and do that. So inverse tan, second function tan, 80 divided by 130. Oh, wait a minute. My calculator is probably in radian mode. Yeah, I want to move it to degree mode because I turned it off. And then again, inverse tan, 80 divided by 130 should give me an angle of 31.6. 31.6. So that is the angle of the depression due to our alternate interior angle rule, as these two lines are parallel, this one and this one. Okay, so that's all the examples I'm going to do. If you would like some extra practice, go ahead and try these ones with isosceles triangles. Whenever you see an isosceles triangle or any other triangle, you can just turn it into two right triangles to get the different lengths. So thanks for watching, and see you next time. In order to do that, we know that parallel lines. If these two are parallel, then let me go ahead and put it, first of all, before I jump into it, let me put a question mark here and call that x. X equals, we know that alternate interior angles are these two here, so that would also be x. So once I calculate this, I know